Good morning, Angela.
Good morning.
How are you on this windy day?
I am doing pretty good. What about you?
Good. Good. Okay, we get into a new section this morning. Let's see, this is called Equations and Inequalities. These are fairly straightforward. How about number 1?
On that one, I would divide both sides by 4 and get 9.
Okay, good. You saw the shortcut. The long way would be to solve for x and then answer that. And in fact, most of these have a shortcut like that.
Okay, they got me.
Okay, how would you produce 7x minus, well, first of all, you can solve it the long way, right?
Yes.
Which is to solve for x and then whatever x is, figure out what this is.
Right.
Well, to come up with the expression 7x minus 10 directly, why don't I subtract 20 from both sides? Or I could do it in 2 steps. I could subtract 10 from both sides, and then subtract 10 again from both sides. Notice that the left side becomes 7x minus 10 if we subtract 20 from both sides. So the answer would be D.
24.
Right, without having to solve for x.
Okay.
Not that that's bad, it's just that these recognitions will maybe take 15 or 20 seconds off the problem.
Right, which is important.
I guess when you add them all up, of course it's also important to know when you don't want to solve for that. In other words, if you look at number 3 and we examine the relationship between 4x plus 13 and 7 minus 2x, there's not much there. It's not like this is a perfect multiple of 2 of that or anything. So in this one, just recognize that it's straight out solving for x. So what do you get?
Let's see, I'm getting -1.
Okay. And number 4.
Well, I guess once again I would just solve for x and then square
Yes.
both sides.
Now, notice that you spent about 15 seconds looking for a shortcut, right?
Yes, I did.
Because x squared minus 4 is difference of perfect squares, and this looks like it might be one of those things, but they're trying to trick us because this factors into x minus 2 times x plus 2. So it's not really have anything to do with x minus 4. So absolutely the straightforward way to solve this is to easily solve for x. X is 13, and then 13 squared is what? 169 minus 4. So it would be 165. So that looking for shortcuts can be a dual-edged sword. It can cost you 15 seconds sometimes instead of saving you 15 seconds. Okay. See how good your algebra is.
Okay, so it looks like I'm solving for x to come up with a, b, c, d.
Okay. That's correct.
So I get the x's on one side.
Okay, so what's the next line I'm going to write?
So it's ax plus dx equals c plus b.
Okay.
And then divide both sides by, can I do that? A plus d? Oh no, factor out the x.
There you go.
And then divide by a plus d.
That looks like A. Okay.
Well, it looks like once again it's just straight across math.
Okay, so what's the second line? It is straight across math, but there are a couple of different techniques you could use here.
Okay, what I would do is make a common denominator of 18x. Well,
Okay. Well, notice that the common denominator of 9 works just as well. And the advantage of using 9 is it makes all your numbers smaller. So there's less likelihood of making an arithmetic error.
We can do 9 even though we have a 6?
Yeah, because what am I thinking? Excuse me. Early in the morning, I guess. No, you're absolutely right. It's 18. Okay, so I've got 6/18 x plus 3/18 x plus 2/18 x equals 33.
So that ends up being 11 over 18x equals 33. And then multiply both sides by 11/18.
Actually, I want to make sure you don't get this backwards. You want to multiply both sides by 18/11ths.
Yeah, oh, okay. Okay.
Because notice if you multiply both sides by 11/18ths, the left would not reduce to x.
Right, okay.
You have to multiply. The other way to look at it is you could multiply both sides by 18 and then divide both sides by 11. Almost, to me, it's easier doing that in 2 steps than 1 because I know for sure I'm not going to get it backwards if I do it in 2.
All right.
You know what I'm saying? Multiply by 18 and then divide by 11 instead of trying to figure out the perfect fraction to do it in 1 step. And then notice they almost always give you shortcuts in the arithmetic. So that would be 50. X equal 54. How about number? I'm sorry?
I was just going to say on number 7,
Huh?
it looks like all you would need to do is, oh no, you wouldn't.
No, you were right. You were right.
Square 11?
Uh-huh. Because this is 3x minus 4 is all in parentheses. So, in other words, if this is an equation, I can substitute 11 for 3x minus 4 and just take it over here and say, what is 11 squared?
Okay. So it's 121.
Right. It would have been different if this wasn't in parentheses or something.
Okay.
Okay, number 8. You remember how to do these?
Okay, let's see, number 8. I would make the base of 64 as 2, let's see, what would that be? 2 to the 6th?
Correct.
Multiplied by 12 equals 2a minus 3. So then that would end up being 72 equals a minus 3, and then solve for a, which equals 75.
Good. Okay, let's go to the next page here. Oops. I double tap with this cursor isn't that good.
Okay, this one I'm going to need to write out. 3a plus 4b. 50.
Okay, so tell me how you're writing it out.
Well, I'm just going ahead with 3a plus 4b is less than 50.
Okay, the average of them, which means we have to divide that by 2.
2.
And, okay, so that's the first thing.
And then 2b equals a.
Okay, that's the second thing.
And then on the first equation, I multiplied both sides by 2 to get rid of the denominator.
Okay.
And let's see, 2b, a equals 2b. So in the 3a, we could just make that 6b.
Okay. So we now have 6b is less than 100, but notice what they're asking. Asking for the largest possible integer value of a. So at this point, let's re-examine how we're doing this problem. How should we be doing this problem?
I don't know.
We should be back solving. The reason is what is the largest possible integer value of a? Well, that gives us a good clue as to where to start on our back solving. Where are we going to start?
With b.
Actually, since they ask for the largest possible, if we started with b and that worked, we'd still have to try c, and then we'd have to try d, and we'd have to try e. So
Okay.
here's a case where when we're back solving and they're asking for the largest possible, we're going to start with the largest, because if that works, we're done. If it doesn't, then we'll have to do 19, and then we'll have to do 11, and then we'll have to do 10.
Okay.
Okay, so we may have to try all 5 of them, but the math is not that hard here. So could a be equal to 20? We're going to, let's do it. Let me write this up here. A is equal to 2b. And let's test out the scenarios. Can a be equal to 20? Well, what would b be?
10.
And then what would the average of 3a and 4b be?
I don't know.
Okay. let's go up here. Remember that let's change this back to the way it was. So there's the average of 3A and 4B, and if A is 20 and B is 10, what is that average?
15.
Well, it's 3 times 20, so that's 60.
Oh.
Plus 4 times 10 is 100, divided by 2, that average would be equal to 50, which is not less than 50. So, what's the answer?
I got lost. I don't know. I'm at 60 plus 4B, and that's as far as I don't understand how
Okay, when we decided to consider that A would be equal to 20, because A is twice B, that means B is 10. So when I pick answer E, that's the value of A and B. And now, if I want to find the average of A and B, I'm going to plug in 20 for A, 10 for B, and figure out what that number is. In other words, they're not asking for the average of A and B. They're saying the average of 3A and 4B is less than 50. Well, if A were 20, making B 10, the average of 3A plus 4B would not be less than 50. It would be exactly equal to 50. In other words, A cannot be 20.
Okay, but 19 could be.
Well, let's consider 19. As all we have to do is go a millionth of a point from 20 to make this work. So 19 should work. In fact, we don't have to even test it. Well, maybe we do. Let's let A equal, just as verification, now that I think of it. What is B if A is 19?
38.
Half.
Oh, half. That's right.
Because A is 2B. Okay. So now what is the average of 3A? That's 57. Plus 4B. Well, 4B is 38. And if I divide that by 2, I clearly get something that's less than 50. So as long as those two numbers add up to less than 100, then I'm fine. So 19 works. Considering the question as to whether we need to test it or not, I think we probably do. Because I know that when we change and try 19 instead of 20, since the arithmetic average that we're looking at is not linear, it's not uniform, it's not the same number of A plus the same number of B divided by 2, it's 3A plus 4B. But so I would say we do need to test it. But when I tested it, I easily got a number that was less than 100, making the average of the two less than 50. So 19 is clearly, hold on a second. Oh, it's because it's number 9. Good. Yeah. Okay, the book adds an interesting additional way to solve this, even though I still like back solving it the best. But they say that 3A and 4B is the same as 3A plus 2A.
Oh, okay.
And that average is 2.5a. So I need 2.5a to be less than 50. And now back solving becomes much easier. 20 does not work, but 19 has to. And in fact, if you do this first, then you definitely do not need to test D. Once you see that E doesn't work, you know D has to be the answer.
Okay.
Because we've now narrowed it down to a very one variable inequality. Okay. Speaking of inequalities, just let's cover the one thing about inequalities that's different from equations, and that is that solve that for me. Minus 2x is less than minus 10.
It would be x is greater than 5.
Okay. I thought you knew how to do that. We had been through some before. I remembered you were pretty good with that. Okay, looking at number 10. 1 over a minus b equals 5, then a equals what?
The first step would be to multiply both sides by a minus b. And then divide both sides by 5. And then add b to the other side.
It's this answer right there, C.
Okay.
Good. You're pretty strong on your algebra. If we had to skip any section, we probably could have skipped this section. But let's go through it a little fast. X is equal to 3a plus 7, and y is equal to, what is that, 9a squared? Let me just look in my book. Yeah. So what is y in terms of x? And what's the process you're going to use here?
This one, in terms of x. Well, if I were to square the 3a in x, I can't do that though, huh? I'd have to, well, and I could square the 7 to 49.
Let's examine the exact methodology that's going to be the most efficient here.
Okay.
We're looking for y as a function of x.
Okay.
Okay. So I already have y as a function of a. So if I can solve this equation for a, then I will have a as a function of x, and I can substitute that down here. And then I will have y as a function of x.
Okay.
Okay.
So we would have x minus 7 equals 3a, so divide by 3. So x minus 7 divided by 3 equals a.
Okay, now that's the key thing you want to realize. Okay, now we can just substitute this for a, and I'll have my answer.
Okay, that was much faster.
Well,
made more sense.
Yeah, it kind of, it's a difficult step to figure that out. It is, but you get practice at this a little bit, and it'll come more natural that that's the way we want to proceed. There's probably a number of ways we can actually proceed. We could solve both sides equal to a and then set them equal to one another and then solve for y. That would be another way to go. but I think this is the most efficient. So what do we have here? We have y equals 9 times x minus 7 over 3 quantity squared because the 9 and the 9 cancel. So is that one of our answers? Yeah, x minus 7 squared.
Okay.
And always check your answers before you go any further here. In other words, it might be natural to go ahead and expand that. But then after you do and you look up at your answers, you realize there aren't any expanded answers on there. So you would want to leave it in this form. For y minus 3x equals 5, what is the smallest integer value of x for which y is greater than 100?
I'm not even sure where to start.
Well, since they're asking about y, why don't we solve this equation for y?
Okay. Okay, we'd have 5 plus 3x divided by 4.
Okay. Now we're ready. Now we need y to be 100, greater than 100. So I can effectively substitute 100 for y, figure out what x is, and then know that I need x to give me a y greater than 100. Actually, you know what? Let's just do it the right way. In other words, since 100 has to be, it's almost easier to do it the two-step method, now that I think about it. In other words, the question is, if I do it the right way, the way I really want to do this is like that. They're saying, what is the smallest integer of x that gives a value of y greater than 100? Well, I need to solve this inequality. And if I solve that inequality, I get 3x is greater than 95. So x has to be greater than 95 thirds. So 95 thirds is 31 and 2/3. So if x was 31 and 2/3, has to be greater than that, which is 32.
Okay.
However, I like the first way I did it better because it's not that clear whether this should be greater than or less than. It would be easy to make this mistake. So let's make it equal to. In other words, if we figure out the value of x that makes it equal to 100, what do we get? We get x equals 31 and 2/3. Now it's real easy to see that x has to be 32 and not 31. In other words,
Okay.
it's easier to not get confused. Now, perhaps that wouldn't have caused you any confusion. It caused me a little confusion when I first looked at it. So, to me, it was safer to solve the equation, figure out what value of x makes y equal to 100, realizing that if we increase x, because we're looking at this, if we increase x, we're going to increase y. Now, that's not always the case. If this was a 5 minus 3x, then that wouldn't necessarily be true. Then if I increase x, I'm going to decrease y. So it's important to understand that you have a situation here where as x goes up, y goes up also.
Okay.
Because, in other words, if we solved that equation and we got this, now notice that we can still solve for x. It's going to be 31 2/3. Well, I don't know if it's going to be 31 2/3, but we can solve for it. But now we're looking at a situation where if x goes up, y goes down, because there's a negative sign in front of x.
Okay.
So make sure you know that it's a direct relationship and not an inverse relationship.
Okay.
Before you take this, to me this is like using training wheels here, but it guarantees that we get it right, because I had to think about it for a while before I realized that that was the proper way to do it and not a less than. When I say training wheels, I don't really mean training wheels. I mean, let's make sure we do it in a way that we're 100% sure of the answer and not questioning whether or not we got that direction of the inequality correct.
In this case, if I added them both, let's see, that solves it for A, which would be 2A equals 20. I don't know if this is the right way to do it, but 2A equals 26 divided by 2A would be 13.
Okay.
So if you plug that into one of the equations, B equals 0.
Okay, that's perfectly fine. The more direct way would be to subtract these two equations instead of add them.
Okay.
And if we subtract them, we immediately get 2b equals 0, b equals 0.
Okay.
Okay? So quantity b would be greater.
Since the bases are the same, can we do A minus 1 minus B plus 1?
It's fine. Yeah, you do need to do that way. Just make sure you use parentheses.
Okay.
Equals what?
Equals 8?
Well, it would be 2 to the power equals 8.
Okay, so yeah, 2 to the third. So equals 3.
Okay. And now what do we have? What's the number part of this?
Let's see, A minus 1 minus B minus 1. Well, I ended up with A minus B equals 5.
Okay, that's correct.
And since, oh, I don't know.
Well, if A minus B equals 5, then A equals B plus 5.
Okay, which means it's going to make A bigger.
I guess it does, even if A or B are negative, huh? Yeah, if A equals B plus 5, then A has to be bigger. Okay.
Okay. Okay, so in this case, x can be anything. Or no, it actually can't because it equals. So solve for x.
Uh-huh. So what's the first thing to do to solve for x?
Well, we can divide both sides by 4. Nope, that's not going to work.
The proper way to do this is this. Factor out an x. And now x can either be 0 or x is 3/4. In other words, I'm setting this equals 0 or this equals 0.
Okay.
And in either case, it's less than b. So quantity b is bigger. Let's go back, however, to this step here. I hesitate whether to even tell you this because it's not correct, actually, mathematically to do it, but it is a shortcut. If I divide both sides by x, I get this. And I get this immediately. And immediately I know b, quantity b is bigger.
Okay.
Now, the reason that's not quite allowed is because at this point x can still be 0. So if I divide both sides by x, I'm dividing by a variable that could be 0, which violates that first commandment of mathematics. And in fact, notice that I lose my 0 solution. So this would have been a much better problem if quantity b would have been 1/2. You see why? If quantity...
Yes, because of the two answers. So if you would have only come up with the one answer, you would have said that quantity A was larger when in fact it wasn't.
In other words, if I did this the improper way, by dividing both sides by x, I would have come up with x equals 3/4, and I would have lost the solution of x equals 0. But that's the only bad thing about doing that, is you lose a possible x equals 0 solution. So if you can tell that that's not going to hurt you, it's no big deal. Yeah, probably it's always best to always do this the proper way. This would also have been a better problem if they'd have just switched the numbers. And they'd have made this 3x squared equal 4x. Then my two solutions would have been 0 and 4/3.
Okay, my first inclination is going to be to add them and divide by 3.
Yeah, in other words, when you add them, what nice thing happens? The nice thing that happens is you end up with 2 of everything. We end up with 2a plus 2b plus 2c. And we know that that's equal to 6. So the average, yeah, if I want to divide everything by 6, I will get a plus b plus c divided by 3 equals 1. And that is the average of a, b, and c. So they're the same. But the key thing here to recognize is that when you add these 3 equations together, you get the same coefficient in front of each one of them. Because if I didn't, I wouldn't be able to get anywhere. if I told you that 2a plus 2b plus 3c is equal to 6, you cannot tell me what the average of a, b, and c are. It's impossible. So to be able to reduce this and find the average, we need these coefficients to be the same.
Okay. On that one, my first inclination would be to put 3x minus 4 and then multiplied by 2x equals 5.
So that would be 3x minus 8x. So x equals minus 1. What does y equal?
Negative 2.
So which one's bigger?
A.
Okay. 18. Got x over 2 minus 2 is greater than x over 3.
Well, one of the things I could do is just plug quantity b in for x, 12.
Okay, what's that going to tell you, though? And that gives you an equation. In other words, if you plug in 12 for x, you get 6 minus 2, which is 4. That's not greater than 4. So you get 4 is greater than 4. So does that tell you which is bigger?
No.
Not really, not without some confusion. So let's just solve this inequality. You want to be able to solve that inequality anyway. What's a good step for solving equations or inequalities when you have fractions involved?
Get rid of the fractions.
Okay. What single thing can I do as a first step to get rid of all the denominators?
Multiply by 6.
Okay, so now we have 3x minus 12 is greater than 2x. Now it solves pretty easily. Bring the 2x over and you get x is greater than 12. Quantity A is larger. Okay, I must have another page here I need to open. Yeah. Yeah, let's, now, all right.
Okay. Again, my first inclination is always to add them.
Okay, what do you get when you add them? 5r
minus 11s equals 34. So
that's going to create a problem.
right.
So now let's examine another way.
Eliminate?
Now let's subtract them instead of add them.
Okay. Okay, so yeah, the average would be divided by 2, so it would be 5. Is that correct?
That's correct. So quantity B is larger.
Larger.
Mm-hmm. This is a good problem. I like this because adding them didn't really get us anywhere because it gave us
No.
those different coefficients. But subtracting them gave us exactly the same coefficients. And it wouldn't have mattered whether they were 1 or not. That could be any number, and we could have proceeded easily from there. This looks like exactly the same problem we saw in the first test we took, I think.
So multiply both sides by CD to get rid of the denominator.
Okay.
But considering, well, let's see, actually they're both positive.
You know, this is a little tricky. This is a bit tricky. I remember it was tricky the first time I saw it in the test. So what is CD equal to?
Oh, C minus D.
D minus C. I switched the sides.
Oh, okay.
But in other words, I can solve it over there. I got to subtract C from both sides. So if CD is equal to D minus C, and CD is positive, which is bigger, D or C? And we know it's positive because both C and D are positive, so the product C times D is a positive number.
Okay.
And if it's a positive number, then D has to be bigger than C.
Okay, got it.
Okay? If this were a negative number, C would have to be bigger than D. Okay. All right, we got through more than a complete practice session here. Let's see. That was equalities and inequalities. Next we have word problems.
Oh, and I really am bad at word problems.
I know, everybody
I've been
is.
working on these a lot, trying to figure it out.
Everybody is. I think I can be of help because I'm convinced the most important thing you can do on a word problem is always do the same step even if it seems completely unnecessary.
Okay.
And that step is define your variable and specify what it is. Now, this is a problem that is the quintessential back-solving problem, right?
Yes.
It's like an age problem. Or
Yep.
she has marbles, she has 10 more marbles than her, and the other one has 3 times as many as both of them. And those are fabulous problems for back solving, but they're going to make us do it the hard way here. So let's have a look at the problem. How much money in dollars do the two of them have? Well, let's set up some variables. I could say, usually you look immediately to the last sentence to define your variable.
Okay.
In this case, I don't really want x to be how much both of them have. It makes it hard to write out the equations I'm going to need. So how about if we let x be how much Howard or Ronald has? Which one should I let it be?
Howard?
No.
Because
Howard has 3 times as much as Ronald, it's easier to make X equal Ronald's amount.
Okay.
You see why? Because now 3X is Howard.
Oh, okay.
I could have let Howard be X, but then I would have had to use 1/3 X for Ron. And I would prefer to stay away from fractions.
Okay.
Okay? So I have to kind of examine the first sentence. I could even use 2 different variables. I could have said X is Howard, Y is Ron, and worked out the thing in 2 variables. But since one of the equations is so straightforward that Howard has 3 times as much as Ron, it's really easier to leave this in one equation. I'm sorry, it's easier to leave this with one variable only rather than introducing a second variable.
Okay.
We don't need to, because by saying that X is Ron and Howard is 3X, we've incorporated that equation. They tell us that Howard has 3 times as much as Ronald. Okay? So starting with the second sentence, give me an equation that fits that sentence.
It looks like, let's see, if Howard gives Ronald $50, so 3X minus 50, Ronald will then have 3 times as much money as Howard. So equals 3 times 3X. He will have 3 times as much money as Howard.
Okay, let's see. We got Howard. This is Howard's amount after he gives them $50.
$50.
And then Ronald's going to have 3 times that amount.
Oh, 3 times the 3X minus 50.
Right. So he will now have 9X minus 150. Now I'm confused. And I thought I was the expert on word problems. Hold on a second. Let me think about it.
Okay.
So if Howard gives Ronald $50, then Howard has this much, and Ron has X plus 50.
Oh, okay.
Now it's easy. Now they're saying that Ronald's amount, X plus 50, is equal to 3 times Howard's amount, 9X minus 150. Now we solve for X. So we have 8X equals 200. So X equals 25. And at this point, it might be worth checking.
Uh-huh.
In other words, if X is 25, Ron started with $25, Howard started with $75. If Howard gives 50 away, he'll have 25, Ron will have 75, Ron will have 3 times as much. We're correct. Whether you'd want to go through the check phase or not, I would say probably on this, because this was a little more difficult to set up than normal. They trickified it a little bit. But still, that first step, I think, is huge. And again, you can see why we didn't want to let x equal how much the two of them have together. It would have been really hard
Right.
to do like that. Okay, let's try this one. I don't know if you can read this or not. It's all so blurry. In the afternoon, Beth read 100 pages at the rate of 60 pages per hour. In the evening, when she was tired, she read another 100 pages at the rate of 40 pages per hour. What was her average rate of reading for the day?
I believe, wouldn't it be, I know how to do this one. It would be 100 times 60, which would be 600 pages.
Okay, hold on a second. I think you know how to do this also. And this is not that different from an arithmetic mean problem.
Okay.
Because they're asking for an average. We don't want to compare the average of 60 pages per hour versus 40 pages per hour. That's the mistake. It's definitely not 50 pages per hour. What we want to do is figure out how many hours she read in the morning, how many hours she read in the evening, and the average for the day is the total number of pages read divided by the total number of hours read, right?
Yes.
So it's the same type logic as we're going to use with arithmetic average problems. We're going to look at it as totals. So how many hours did she read in the afternoon? She reads 100 pages at 60 pages per hour. How many hours is that?
That's 60 pages in an hour. 100 divided by 60, correct?
Correct.
So 1 2/3
hours. How many hours did she read in the evening?
2.5.
Okay. So now her average rate of reading for the day is the total number of pages she read divided by the total number of hours she read. Excuse me, not 2.5. 4.16.
Yes.
And you can certainly come up with, even though that's a bit of an approximation because it's 4.166, that will narrow it down close enough to pick from these numbers.
Okay.
I think if I divide 200 by 4.16, I get 48 and change. And we know this number has to be less than 50 because 200 divided by 4 would be 50. So it's going to have to be a number less than 50. You could almost guess 48 and be right. Okay. Why don't we stop there?
Okay.
And we'll pick up with the rest of these word problems on Thursday, right?
Yep.
Okay. Angela, I'll talk to you Thursday morning.
Okay. Thanks, David.
Sure. Bye-bye.
Bye-bye.